So this is a way to test understanding of derivatives rather than just taking derivatives or talking about rates of change. Take a look at what it does to the graph. First of all, this is just function information, just telling you when x equals -1 and when x equals 1, the y values are 0. So let's say over here is -1, over here is +1. That's where it hits the x-axis. And then it goes through 0, 1, so go up to a height of 1. That's another point. And now the derivative at -1, the derivative at 0 do not exist. That could come from having a sharp point like this, a cusp. It could be that there's a corner, then the derivative does not exist. There could be an asymptote, or just in general the function is not continuous. So there's all of these possibilities, and right now I'm not sure which it is. Although since this does have a point here and does have a point here, it's probably not these guys. But since I'm not sure right now, I'm going to come back to that one later. I'll go on to, so I'm done with that, but I'm skipping this. Now this says the derivative is equal to -1. So that means the slope of the tangent line is -1. And it doesn't change. So that means it's got a line and it's a slope of -1, and that says to the left of -1. So a slope of -1 will look something like this. And now, because of that, I think that it's a corner. But let me go on one more, and it says the slope is 1 between, when x is between -1 and 0. So that means that it would be a line with a slope of 1, like that. So now I have this part done. That's a corner. And I've got this part done. Next, between 0 and 1, the derivative is negative. So that just means that it goes down. It can go down as a straight line or go down as a curve, but it goes down. So that would be negative slope. And then this one is saying that the slope is positive on the right hand side. So you could just make it go up. That takes care of that. And now this is part corner and part, so it's part this and part that. And so the derivative does not exist. I'm done with that. And that's the whole thing.